In the given figure, capacitors are connected as shown across the battery voltage 500. Determine the equivalent capacitance of the network. Then the charge on each capacitor. No, the charge on the capacitor is the charge on the plate with the higher potential, equal and opposite to the charge on the plate with the lower potential. First, we have to observe the diagram carefully. If we start from point A to B one capacitor, B to C another capacitor, C to D is another capacitor. So we can see clearly that these three capacitors are connected in series. C1 and C2 as well as C3, these three are in series. Then C4 is in parallel. So we'll start solving it now. Series combination. When three capacitors are in series, 1 by C is equal to 1 by C1 plus 1 by C2 plus 1 by C3, but all are having same values, that is 10 picofarad. So 1 by 10, 1 by 10, 1 by 10, 3 by 10. But C is equal to, you have to do the reciprocal, 10 by 3 microfarad. Now, this 10 by 3, all three equivalent is single capacitor 10 by 3. It is connected parallel across C4. So how to do the final one? That is CS with C4. These three is replaced by single capacitor 10 by 3. That is in parallel connection with C4. Its value is 10. So parallel direct addition 10 by 3 plus 10. That is 10, 3 common denominator. 10 3s are 30, 30 plus 10, 40. So 40 by 3 microfarad. So we got the equivalent capacitor. Now, we have to find the charge on each and every capacitor. If you come across here AD, here battery potential is 200. It is clearly understood that is parallel connection. So, potential across C4 is 500. C4 value is 10. What is the charge? First, we'll start finding the charge across C4. That is same voltage. So, charge across C4, Q equal to CV formula, Q across 4 equal to C4 into voltage, C4 value equal to 10 and voltage is 500, 10 into 500 that is 5000 microfarad because charge is in terms of micro capacitor. Micro coulomb, mu C. So, a charge across mu 4 C4 is 5000 microcoulomb. Now, we have to find the charge across each and every capacitor. These three capacitors are connected in series. That's equivalent is 10 by 3 and voltage is 500. So, we will find the charge. Now, Q in series. These all three are in series. Charge across these three equal to CS value multiplied with potential. CS is 10 by 3 with the potential 500. So 5000 by 3 that is 1667 microcoulomb. This is the charge across this. As they are connected in series, charge across C1 equal to charge across C2 equal to charge across C3 that is equal to 5000 by 3 microcoulomb. That is 1667 microcoulomb.